All right, so for this first one, they're telling us this area from -4 to -1 is called A1, and then the area from -1 to 4, they're calling A2. And then they're asking us to evaluate this. So integral from -4 to 4 would be the whole thing. So that would be A1 minus A2. And the reason you have to subtract A2 is because that is a negative area, or an area. It's below sea level, so that's going to get subtracted. And then minus 2 times the area from -1 to 4. So that would just be this portion. So again, that would be negative A2. So we have A1 minus A2. These negatives will cancel, so plus 2A2. And then combining these like terms will give you A1 plus A2. So that one should have been D. So did you put D and it marked it wrong? Is that what we're saying there? Because if so, I can, it means I just accidentally clicked the wrong thing. Or is that not the case? Like, did anybody put D, but it marked it wrong for you still? Okay, I'm gonna assume that everything is okay then. Please jump in there if you have a question. Or wait, okay. Sorry, I didn't have my chat up, I couldn't see that. All right, so number 2, integral from -5 to 2 f of x dx is -17, and then they give us a whole bunch more information. Integral -5 to 2, that's gonna be -4. What is the value from -5 to 5? Okay, so it looks like we're going from -5 to 5, but we're doing a rest stop at 2. I always just in my mind view that as like a journey from here to here, and we're going to do a rest stop at 2. So integral from -5 to 2 plus the integral from 2 to 5 is going to be the whole distance. And this is the one that we're trying to find. So integral from -5 to 2, they said was worth -17. So that'll be -17 plus, and then we have to get this one. Now they said integral from 5 to 2 was -4. So from 2 to 5 is going to be +4. They switched the boundaries, so it's going to be the opposite result. And so -17 plus 4 will be -13. And so that one is B. All right, so number 3, if a trapezoidal sum over approximates and a right Riemann sum under approximates, the value of this area, then which could be the graph? So if a trapezoidal sum is over approximating, that means your graph needs to be concave up. Darken this. If you have something that's concave up like this, your trapezoids are going to be really slightly above it. So we need a graph that's concave up, and it said that a right sum is going to under approximate. That means we need to be decreasing. So if your graph is decreasing, the right side is lower down than the left side. So a right Riemann sum would under approximate. So we want a graph that is concave down, or I'm sorry, concave up and decreasing, and the one that's doing that is A. All right, for this one, we have this piecewise function. We want the area under the graph from 1 to 5. So I need a picture of this. We have a flat line at 2, just a constant function of 2 for everything smaller than 3. So that is going to look like this. and that would be an open circle there. I think these end up connecting though. And then we've got x minus 1 for everything bigger than 3. So yeah, if I plug 3 into there, I'm going to get 3 too. So they're going to connect. And then that slope is a positive 1. So if I go up 1 over 1, up 1 over 1, it's going to do something like that. So this is my graph, and we want the area from 1 to 5. So that would be this. That is a really strange shape. I'm not going to be able to get that area all at once, so I'm going to split it right here at 2. So the first shape is just a square that's 2 by 2. So that area would be worth 4. And then this is a trapezoid that is on its side. So to review the area for a trapezoid, it is 1/2 height and then add the bases together. So for this trapezoid, that's going to be 1/2 times 2. This is the height because again, it's on its side. And then adding the bases, this one is 2 and this one is 4. So that would give us an area of 6, and then we add that together and we're going to get 10. All right, the graph of a function is shown from 0 to 3. Which of these has the least value? Okay, so this is the actual true area, whatever it's worth exactly, that definite integral. And then we've got a left sum, a right sum, a midpoint, and a trapezoidal. It's going to have to either be left or right, because the true answer is going to be, somewhere in the middle of all these estimations. And the midpoint sum and the trapezoidal sum are going to be better estimations. They're going to be really, really close to this. The two that are going to be, not as great estimations are left and right. So if you're asked for the least value, it's going to have to be one of those. And for this graph, it is decreasing. So that means the right side is lower down than the left side. So the right sum is going to have to be the smallest one. All right, for number 6, we want the area under this graph from 1 to 4. So I'm going to need to draw a picture. The point of this V shape is going to be at 3. So I'm going to go ahead and plot that. I've got 3, 0. Or you could think of it as plugging in 3. 3 minus 3 would give you 0. And then I'm going to plug in the boundary points too. So if I plug in 1, that's going to give me absolute value of -2, 2. And if, oh, sorry, I didn't plot that at 1, 2, though. I plotted that at 0. I apologize. Sorry, that should be at 1. And then if I plug in 4, I'm going to get 1. So this is that V shape. And I mean, the graph would continue on. It's just I only want the area from 1 to 4. So you get these two triangles, like lopsided kitty cat ears. And your area of a triangle is 1/2 base times height. So the base for this first one is 2. The height is also 2. And then the other triangle, 1/2 base times height, the base and the height are both 1. So this is going to be 2 plus 1/2. So 2 1/2 or 5/2, which is. For this next one, they give us the numbers in a table. It says the function is continuous. Here are all the intervals. We want the approximation for a left sum. We're going to have to do all of the intervals separately because they are not a uniform length. So first sub-interval is from 2 to 3. So that's a length of 1. And for a left sum, we're choosing between these two f of x values. The one on the left is 6. All right, next subinterval is from 3 to 5, so that's a distance of 2. And out of the two output values, the one on the left is -2. And then the next subinterval from 5 to 8 is a distance of 3, and the value on the left is -1. And then from 8 to 13 is a distance of 5, and the number on the left is 3. So this is 6 minus 4 minus 3 plus 15. So gosh, what is that? -2 minus 3 would be -1 plus 15 would be 14. So B. Right, here we have integral from 1 to 10 of this function is 4. From 10 to 3 would be 7. We want 1 to 3. So again, we're going on a journey from 1 to 10, and we're doing a rest stop at 3. So from 1 to 3 plus from 3 to 10 is going to give you all the way from 1 to 10. So let's plug in what they're giving us. From 1 to 3, that's the one that we're looking for. So this is kind of my unknown here. That's what we're trying to find. Plus from 3 to 10. Well, instead they gave us from 10 to 3. So I'm just going to need to do the opposite of that. So that'll be a -7. And then from 1 to 10, they said was 4. So the one that I'm looking for has got to be 11. So that was E. And then last one, we're given this table of values. Sorry, this is so small. Please zoom in further. Hopefully we will be able to get into College Board soon, and I won't be having to copy and paste these questions anymore. So we've got functions continuous. They gave us these values. Here are subintervals. This time they want a trapezoidal approximation from 2 to 8. So once again, this is your formula for the area of a trapezoid. And we're going to have to do them all separately because, again, these subintervals are not all the same length. So we've got 1/2. The height is the length of the subinterval because, again, all the trapezoids are turned on their sides. So the height for the first one, from 2 to 5, that's going to be 3. And then we're going to add the bases together. So 10 plus 30. And then the next one, 1/2 from 5 to 7 will be 2. And then add the bases together. So 30 plus 40. And then the last one, from 7 to 8 is just 1. And then add these bases, we'll have 40 plus 20. Now it's non-calculator, so we're going to have to get through this somehow. 10 plus 30 would be 40. Half of that would be 20 times 3 would be 60. Here, the 1/2 and the 2 cancel, so that's good. And then this is just 70. And then here, 20 plus 40 would be 60. Half of that is 30. So 160. And so that is C.